students. And so far, what we're seeing as educators is that what we've done in the past is not working. And that's what we're here to talk about with you today. A couple of quick housekeeping tips. If you could please mute yourself while you're on the webinar. You're welcome to add comments through your webinar dashboard, and only AgileMind will see your comments. We are recording this, so you don't need to feel pressured to take notes. We'll be on for about 45 minutes, and we will have a Q&A at the end. And to engage you in participating today, we will have a series of polls throughout the session, and we highly encourage you to participate in those. Finally, we have our agenda. First, we are going to define intensification, talk about the theories and research behind it, and we will look at some data from districts who have implemented intensification strategies. And then lastly, we will hear firsthand about the experience of implementing intensification from one of its most fervent supporters. So to help us begin, we would like to get a sense of what you think about in your district as your greatest challenge. What is the thing that keeps you up at night when you think about the challenges you face in your district? If you could just select. Interesting. So we see 49% of the group cites lack of student motivation and commitment to learning, and most of those who don't cite all of the above. Thank you for that. So we'll address all of those things as we go through this webinar. And I would like to officially welcome you to the first part of our three-part series on intensification versus remediation, the problem and the intensification solution. Our three panelists today are myself, Nicole Whitaker. I'm the Director of Professional Services in the Mid-Atlantic and the Northeast for AgileMind. And my job is to work directly with our partners and their teachers to ensure a successful implementation. At AgileMind, we focus on teaching and learning tools and curriculum for middle and high schools that are aimed at increasing the number and diversity of students that succeed in math and science. Additionally, we have with us Cassie Cook, who is the Manager for Online Course Programs at the Charles and Dana Center at the University of Texas at Austin. And in her role, Cassie builds deep expertise in instructional theory and then helps translate that into cutting-edge programs and professional development. Cassie was actually a classroom teacher for 19 years who was nominated 5 times for a Presidential Award for Excellence in Mathematics and Science Teaching. And we're absolutely thrilled that she's here today because that combination of the research and practical background gives her an unusual ability to talk about both the theory behind instructional techniques and also how that theory can be translated into classroom practice. And Kathy's going to lead us off in a minute by discussing the principles of intensification, which is a key area of focus in the Dana Center's work to support student success. And lastly, we have Donna De Sena, who is the secondary academic coach at Hillsborough County Public Schools in Florida. Donna is the spearhead of the Hillsborough County implementation of an intensified algebra program in 27 schools. So now that I've introduced everyone, I'm going to hand it off to Kathy so that she can dig into the architecture of intensification.
Thank you, Nicole, and welcome everyone. So what exactly do we mean by this thing we call intensification? So intensification is a very different approach to serving underprepared students. many approaches to these students are based on a deficit model. We tend to focus on remediating students' weaknesses and skills. The Dana Center's approach to supporting students who struggle academically is built on a core insight emerging from the work of Uri Treisman, who is our executive director, that struggling students benefit most from an experience of intensification that builds on students' assets to help them learn on-grade level content while at the same time addressing deficiencies in their preparation. So this means that students need a challenging curriculum, but one that uses additional time to incorporate targeted scaffolding, supports, and interventions, including interventions that address the non-cognitive factors that affect student success. So as you think about these three things, more time, a challenging curriculum, and targeted interventions, I'd like to focus on the first aspect of intensification, more time. So I have another question for you. Does your district provide extra instructional time for struggling Algebra I students? Again, as with Nicole's question earlier, you'll have about 30 seconds to respond to this. We'd love to hear how people are dealing with this very challenging issue. So just over half give an extra support period. Small number have a double period, and we know that research has been very uneven over the years about the use of double period scheduling. Some are very successful, some not so much. We can talk a little bit more about that throughout the course of this webinar. So an interesting mix. So let's dig in a little bit more into this idea of intensification. I want to share with you just one little taste of some promising results from a couple of places that have employed an approach to intensification rather than the more traditional approach to remediation. So you see on the left a comparison of students who experienced an intensified algebra program with those who were in a regular Algebra I. You notice that they outperformed on the end of course exam. This is a state exam. Not only did they outperform on the passing rate, but they also very much outperformed on the commended rate, which is a higher level than simply just passing. On the right, you see gains from the Explore test to the Plan test and two ACT tests. Intensified algebra students at a school, again, outperformed the other Algebra I students at the same school and also outperformed the national average annual growth. Some promising results. Nicole will show you some more information later, but we wanted to give you a taste of some successes. So intensification draws from a number of key findings from research. Students need challenging tasks. They need explicit routines. We have to address their misconceptions in very strategic ways. We have to attend to practice, and we have to think carefully about how we do that. We have to leverage formative assessment as a key instructional strategy. And finally, we have to build students' beliefs about their own intelligence, because if we can do that, we can increase their motivation and effort to learn mathematics. We're going to dig into each one of these a little bit more deeply now. So let's talk a little bit about the importance of tasks and how they're used in instruction. So if you want to maximize learning, every finding from research says start with rich tasks and then implement them in a way so that you maintain the cognitive demand. I know that all of you have seen examples of instances in which students have been given a challenging task and then all of the rigor has been taken away because of the way the task is facilitated. So the task is important, yes, but also the way in which students are led to engage with the task. So the importance of launching the task in a way that students can engage with it. How are students supported in investigating the task? What is the teacher's role in facilitating an investigation versus leading them through doing the task? These are two very different things. One lowers cognitive demand, one keeps it high. And then once students have investigated and explored, the role of the teacher in debriefing what students have done and in drawing together the important mathematical ideas that students have experienced is key. Again, if you really want to increase student learning, start with a rich task, pay attention to each of the phases of student exploration, maintain cognitive demand through all the parts. Hugely important. Another key intensification strategy is actually borrowed from the special education world. Our colleagues at the Center for Research on Learning at the University of Kansas really stress the importance of learning routines to help students organize and make sense of learning. Many students don't know how to do this, and so we have to teach them these learning rituals. We have to explicitly develop and teach students proficiency with these. So here's an example of what you might do. You might employ an agenda for the day in which you preview with students the goals for the lesson. Or each day you might wrap up the lesson by asking students to describe an important idea from the lesson, then explicitly connect activities from the lesson to the homework to be done that night. You might create a homework processing routine that puts the responsibility for doing and learning from homework on students with built-in peer-to-peer accountability. However, as I said earlier, whatever routines you choose, you have to teach them explicitly to students. You have to have them practice them just as you would with mathematical content. Another strategy that's important to build on from research is the notion of building academic literacy. We know that many students who struggle in mathematics also struggle with reading to learn. And so Lewis and Kim Gomez from UCLA gave us some really good advice. They specialize in supporting literacy in the content areas. You all know that many people use graphic organizers, all sorts of different kinds of graphic organizers. With graphic organizers, the challenge is that students often get caught up in understanding the structure of the organizer, and the very thing that you want to give students to help them provide focus and organization instead becomes a distraction. So the Gomez's gave us this advice. They said keep it simple. So one of the things that we like to use in our work with intensification are double and triple entry journals. You can use these in lots of different ways. Because the structure is very simple, just a simple 2-column or 3-column structure, it allows the students to focus on the content of the organizer and not get caught up in the organizer itself. So you might think of a math journal where students are doing vocabulary. So the columns might be, here's the word, tell us what the word means in your own words, and then give an example or an illustration of the term. That's a vocabulary support. Another thing you might think about are actually building 3-column journals where students are explaining and connecting mathematical concepts. So I think of one where a student might be exploring how many different kinds of solutions a system of equations might have, whether it has a single solution, multiple solutions, or no solution. And so you might start out saying, here's the case, one solution, no solution, many. Here's what it looks like graphically. Here's what it means, and here's how I might see that happen through solving it algebraically through an equation. So helping students organize their thinking through these simple graphic organizers can be a huge literacy support in helping to learn and communicate mathematics. Another finding from research, hugely important, some work that was done by Alan Bell and Malcolm Swan, who are at the Shell Center for Mathematical Education at the University of Nottingham, is around this notion of misconceptions. Much traditional remediation attacks student gaps through just continually reteaching skills and concepts, versus this idea of surfacing student misconceptions, so giving them tasks and experiences that are intended to elicit misconceptions. Sometimes it could be by showing students worked examples and they're asked to analyze the error or to determine if there is no error and explain why or why not. As students do this work, the teacher is made aware of what misconceptions students might have, and they can very efficiently and directly address those misconceptions as the student brings them forward. Hugely important strategy. Another very efficient repair strategy and also review strategy is this idea of spaced or distributed practice. So compare this to the notion of what some people call crammed practice, and this can manifest itself in lots of ways, from how we help students develop fluency with skills to how we help students prepare for tests. The idea that, and we've all been there when we got ready for an exam, is it more effective and do you retain information longer if you cram for an exam the night before, or if you try to schedule shorter bursts of study and practice leading up to that exam with breaks in between? Research says that distributed practice can be a very effective strategy to help students learn and retain that learning, not only knowledge but also skills. Formative assessment is a hugely important strategy in helping struggling students. So we've learned a lot from the work of Dylan Williams and others, and I know all of you are familiar with both inside the black box and working inside the black box. But this idea that using assessment for learning and inviting students into the assessment process so that not only is a teacher adapting instruction to meet student needs based on what an assessment is saying, but students are adjusting what they need from the teacher, and they're actually understanding that assessments aren't things that are done to students, but they're things that are done with students, and students are a partner in the assessment process. So you can build, again, explicit routines around processing assessments and helping students think about how they learn from their assessments and how they ask better questions about what they don't understand. Formative assessment can be hugely important in supporting struggling students. And as we think about the other non-cognitive factors, we know that many times students who struggle academically or struggle in mathematics are struggling not only because they have gaps in mathematics, but because they have other issues related to their understanding of themselves as learners. They identify themselves as either being part of a math classroom or not part. They think they don't have the math gene, they're not smart in math, they'll never be smart in math. So what we want to think about is strategic intensification that can transform the way students think about themselves as learners. This can develop student motivation and commitment to high achievement, and it can foster skills that sustain students' productive engagement and persistence in challenging academic work. If we can teach students that intelligence is not fixed, but that it's malleable, and that with the right kind of effort they can get smarter in math, we can really help students become more effective learners. But if you do that, you also have to then give them rich mathematical experiences that allow them to struggle, but you also as a teacher have to give them scaffolded support in that struggle. And in that way, students can learn to productively persist through challenging problems and really can have that sense of satisfaction and know that, wow, I could get smarter in this particular area of mathematics. So if you think about this rigorous algebra curriculum, intensification as we conceptualize it at the Dana Center doesn't give up any of the math. There are core ideas that students need from algebra to help them be successful in later mathematics courses. So we're going to start with that core. Then within that, we're going to wrap in all of these targeted supports. We're going to build in the structures and routines and tools to organize learning. We're going to help students shape their attitudes. We're going to work on this efficient review and repair. We're going to distribute practice throughout the course, leverage formative assessment, build in the literacy and language supports. And then if we really want to help teachers be successful in this approach to intensification, we absolutely have to build in good supports for teachers that help them enact the approach. So when you think about your students, the ones who are currently 1 to 3 grade levels behind, and you think about what you're doing for those students and how you're addressing those students' needs, how different is what you're doing from what I've described as intensification? Again, another question we'd love to learn from you. So many of you are including a lot of these components with other different programs. So I see that it seems that these chords that I've been speaking about resonate with you. So it'll be interesting to learn from you about how you're doing these things. I do want to hand it back to Nicole at this point so that she can talk to you a little bit more about some other things that we're learning from our work with districts.
Thanks, Kathy. So we're going to look at two slides here that have, in the first one, slides showing results in specific schools that used these targeted intensification strategies. And then in the next slide on your screen, you're going to see data from entire districts that implemented this strategy. So I'd like to direct your attention first to the graph on the right-hand side. And this is coming after a year where only 31% of students taking the Algebra I end of course exam, the Regents Mathematics exam, passed, so 31%. That following year, one school implemented an intensified algebra program, which included all of the strategies that Kathy just described. That year, those students performed at a 73% pass rate, which is an increase of 136%. And then on the left-hand side, you have another school in Glacier Peak, Washington, where these strategies for intensified algebra were implemented only with the lowest students in the building. And as you see on the far left-hand side of the graph, that first red bar, those are the passing scores of those lowest performing students. And you can see that they outperformed their peers. And then here we have results from two districts in Florida. So on the left-hand side first, we have Collier County, which implemented a targeted intensification strategy with their lowest performing students. Again, these are students who earned scores of 1 and 2 on their algebra end of course exam. And then after implementing intensified algebra, they grew by almost 3 times their pass rates to start. So on the left-hand side, you see the lowest performers, level 1, grew by almost 3 times, and then the level 2 students grew by over 3 times after taking this course. And then finally, on the right side of your screen, you see Hillsborough County. This graph shows the percentage of students to gain 1 level or more on the Florida end of course exam. And you can see that more students in an intensified algebra program grew a level than those in a traditional algebra program. And you're probably wondering right now how these results happened. And to tell you a little bit more about that, we have Donna De Sena, who is actually from Hillsborough County, Florida, who will tell us more about how this happened.
Hello, everyone. I'm Donna from Florida. I just wanted to start by saying that intensification can drastically change the culture of learning for your students and for your teachers. I'm in the 8th largest district in the nation, and my personal experience has been in charter, public, and private schools ranging from kindergarten through 12th grade. About 4 years ago, I transitioned into a new position created by my school district to support the lowest performing high schools. As part of my job, I was asked to find interventions and supports to increase student achievement. Being that I had just left coaching in a K-8 setting, I could easily see structures and supports that were missing from our struggling 9th graders. Overall, I saw that teachers were the experts with all the content knowledge and that students would just sit idly and take notes. I found it to be strange that for our struggling students that they received the same treatment per se, like the same curriculum and the same support as their peers, especially because they were 2 proficiency levels behind their peers. After 6 months in the position, my supervisor and I threw out this wild idea to offer a double block of math for struggling Algebra I students. We thought this would allow us to support Algebra I students while also providing the time to offer the components of intensification. I have to share with you, in all honesty, this did not go over very well with our stakeholders. They just were not buying in. They really saw algebra as algebra and were not interested in taking students out of another course, whether that be an elective, where they felt that it could possibly get students off track for credits. So we began to problem solve and think of what motivation we could get for our top stakeholders. And we sold them on this idea of having 2 periods of math for 2 math credits. What we had shown before was, some of you had said before that you guys offered, I think it was 52%. There was a large percentage of you that answered the poll before that you offer an additional course for struggling students. We've, in our district, typically done the same. It's a different course taught by a different teacher and follows a different curriculum guide, and it's not really in sync with what students would be taking in their traditional math course. So we sold them on this idea of having 2 periods of math for 2 math credits. So in Florida, we would call it Algebra 1A and Algebra 1B. Now this got our stakeholders very intrigued. So to tell you about our first year, we had 11 teachers. We had 6 schools. Of those 11 teachers, 5 of those 6 schools were the lowest performing schools in the district, and then our one school was like a middle of the road kind of school. And I'll be honest with you, in the first 9 weeks, it was really a struggle. We had teachers asking, how do I teach a block? I thought this was going to be easy. We just have them for a double period of time. They struggled with the idea that their kids were going to be in a block and those kids were in other blocked math classes. And how were they going to deal with these students who hated math coming into this course, and now they have them for a 90-minute period of time? So we embarked on some intense professional development and support, and I have to tell you that the tide turned by the end of the first semester. As I walked through classrooms with my supervisor and we brought outsiders in to observe classrooms, we saw students speaking mathematics to each other at a level that we had never seen before. We saw students supporting each other for basic things like to do their homework, to raise their hands to answer the question. We heard reflective dialogue happening between these students. Teachers were amazed when students began to write and complete sentences in math. Then we're even more shocked when those sentences turned into paragraphs of students explaining themselves. Probably the most aha moment for myself was watching students drive the instruction. Having students be the leader in the leader in their classrooms and having the teacher finally serve as the role of a facilitator as opposed to the person who stands at the board and just delivers content was a really mind-blowing moment for me. So the data in front of you right now is from our pilot year, and let me explain it just a little bit because not everybody is from Florida, so that you really understand what it means by level 1, level 2, and level 3. So a level 1 student is traditionally defined as a group of students who are inadequate with the level of success and or students who have challenges with mastery of the standards. So there are lowest performing students have not mastered, the greatest number, the students who have not mastered the standards. A level 3 student is considered a student who has mastered the standards and is proficient. So what you have in front of you is intensified algebra, were the students who received the intensification experience, and the Algebra 1B students are the students, is the course, the traditional course that students would have been placed in without the intensification experience. So obviously what you can see from the chart in front of you is that a larger percentage of students who received the intensification experience moved up 1 to 2 levels of proficiency. The next set of data that we're going to show you is from the exact same year, but what was even more intriguing to look at was not just those students who received the intensification experience in comparison to the students who started at the same level as them, but looking at the Algebra 1 students, which is just the traditional Algebra 1 curriculum, which would be our level 3 students and above, and how students with the intensification experience performed in comparison to those students. So from this graph in front of you, you can see that the students who received the intensification experience definitely outperformed students in the Algebra 1B who were on the same level as those intensified algebra students. But what you can also see is if you look at the students who were in Algebra 1 who were already on grade level, the intensified algebra students after 1 year are now performing on par with their peers. And I know that most of you are going to assume that my district saw this data and they were like so excited, let's put this in all of our high schools. So we have 27 traditional high schools, and then we have ESE centers, alternative ed centers, and career centers. Our district did make the decision to go district-wide with offering students the opportunity to have an intensification experience. However, it was not as a result of the data that you just saw. Our teachers who implemented that program the first year were very vocal about the mathematics that they saw taking place in the classroom. As we did walkthroughs and observers were amazed at how students were working together and speaking together, those observers became very vocal to our school board members and to the district. We watched incentive programs be utilized to motivate learners, and it was actually working with high school students. Thinking back to all those rows that we previously saw in students in our classrooms, students were no longer sitting in rows, and they weren't working by themselves. They were working in collaborative pairs as a team, building a culture of learning and building meaningful learning experiences. Students were encouraging each other and driving that instruction that I talked about, and all they had in front of them to drive that instruction was a wireless mouse and keyboard to navigate the pages that were before them. It was on that peer feedback and observation from students, parents, and teachers that made our district decide to commit to students who were in need of more support in algebra. It was only afterwards when we got that data that it validated the decision that our district made. The data that's in front of you now, we're going to fast forward 1 year. So after the 2012-2013 school year, we implemented in 2013-2014 in 27 high schools and 3 ESE centers. And what you can see from the data in front of you, just to summarize it for you, students who received the intensification experience performed better and were more likely to pass our state end-of-course algebra assessment. Actually, after further investigation into our data, we found that students who were performing not only 2 proficiency levels below, but 1 proficiency level below would benefit from the experience of intensification. So what that allowed us to do this year for the 2014 school year was to open the door to include our low-level 2 students into an intensified algebra experience. So that just gives you a summary of where we were 3 years ago and what results we had last year once we implemented district-wide. I believe that we have a poll for you to do now. So what is the reaction from the data that you've seen today? So it seems encouraging, but you'd like to understand better. So I absolutely wanted to give you some tips and tricks as from taking it from a professional development standpoint into the classroom. So what we've learned over the last 3 years is that whether you're a district leader, a school leader, an educator, you have to model what you expect these students to be able to do. So that means building that culture for learning from the top down. That means modeling for our teachers that we are learning in this experience just like we want our students to learn in this experience, and that we want them learning and working together just like we want our students learning and working together. A really big component of that, and we hear it in education all the time, but it is absolutely critical in this intensification experience, is to believe that all students can be successful with the right supports. I tell my teachers every day is a new day. A student isn't going to be perfect every day, but when they walk in that classroom the following day, it's a fresh start. It's a new opportunity for those students to be successful. That allows us to show students that it's okay to not get everything right the first time, and it's okay if I'm having an off day, because tomorrow I'm going to be able to come back and I'm going to be able to try it again. Something that I believe is important for all districts: there is no one-size-fits-all model. There's no package that can be delivered to every district and it's just going to work. You just follow it from start to finish. Regarding curriculum mapping, it's really important to personalize an intensified experience for your students that meets the needs of your district and that meets the needs of your students. Our first year, we did curriculum mapping. So those 11 teachers I told you about, we curriculum mapped with those 11 teachers, and we found that those 11 teachers had more buy-in in the process because they were a part of that. And we personalized it based on our district calendars, our conflicts that we had, so that it was a unique experience for us in our own district. Some other tips that I have for you: teachers need an avenue to give feedback. They need somewhere where they can have a reflective practice, reflective dialogue between each other, where they can share concerns and challenges and that each other can offer suggestions. It helps us as teachers to build a better practice when we're able to share insights that we have. So to do something like that in our district, we've created a common conference area within the email system, but it can easily be done by like a wiki space or a website, somewhere that teachers can have a voice and feel like they're being heard and getting suggestions. Our first year of the program, there was somebody who oversaw the implementation, but also had 27 other job tasks at their time, and that being me. Our second year embarking on this, knowing that we were going to 27 high schools plus, we knew that we needed somebody who could focus their attention and a designated leader who understood where these students were at and understood the importance of motivating the teachers so that the teachers could be motivating the students. So in the second year, I became that person who took it over and spearheaded it for our district. Now being I have a total of 35 high schools in combination with high schools, ESE centers, and career centers. I will tell you, in my first year, I constantly made excuses for why stakeholders couldn't be trained. I just said they didn't have time, we couldn't add one more thing to their plate. And after a year of implementation, I understood why those stakeholders needed training, and that professional development could have helped them better understand the program that first year. So in our second year, which was our first year of full district implementation, everybody was trained. Teachers spent 3 days in training. Our department heads spent time in training. We trained peers, mentors, assistant principals, principals, district administrators, so that everyone could understand what that intensification experience was for our students, so that they could understand and experience what our teachers were doing. And it was only after that professional development that they truly determined the value of the intensification experience and how important it was to our students and to our teachers that they be supported. I just wanted to leave off with you and take you back to where I was those first 9 weeks where teachers were really struggling and students were really struggling. It was something different than what they had seen before. Students were being challenged at a level that they hadn't experienced, and being asked to think about mathematics and being asked to participate in the mathematics. And what was so important was to, just like I was saying, we have to model for our teachers what we want our teachers to be doing and modeling with our students. We had to teach our teachers how to persevere, just like our teachers have to teach our students how to persevere. And you have to support our teachers just like we have to support our students as they persevere, because now looking back at that experience, they appreciate it that much more that they persevered and made it through, and that students as well as teachers have become independent and collaborative critical thinkers. I'm now going to turn you back over to Nicole, who's going to take us to our Q&A.
Thanks, Donna. So beyond this being compelling in the data and also to district and school leaders, we hear from teachers that intensification has a powerful effect on transforming their own practice and also on transforming their belief system in what their students' ability is to be successful on a rigorous on-grade level curriculum. We are going to open it up now to questions. Please submit your questions through the question part of your dashboard in the webinar. And we're still going to be in listen-only mode, so we will take questions as they come in. I'm going to start first with a question here about intensification as a strategy and how it relates to remediation. And so the question is, how much remediation is done at the start of the year before students get into the on-grade level Algebra I math? And Kathy, I think this is a great question for you to answer.
And that's a great question to be asked. Thank you, Nicole. And I think I want Donna to chime in after I answer, if that would be okay. So I would say that, so it's a very interesting strategy. So we want students to engage with on-grade level content from day one, but we also know that students may have deficiencies that might prevent them from fully accessing that content. So the strategy of intensification takes what I like to call a just-in-time approach to remediation versus a just-in-case approach. Rather than teaching skills that students should have had from previous grades and delaying the algebra until we get those skills, we deliver the skills that they need in support of the on-grade level content. So if I want to teach students about rate of change, which is an algebra idea that relies heavily on unit rates from middle school, for example, I'm going to do some review of ratio and rate, but I'm going to do it in the context of showing students immediately how that's connected to the algebra that they're learning, which is on grade level. So students don't get bored, they don't get turned off, they don't disengage, because they understand why they need to know this pre-algebra content in order to be successful with the algebra. I mean, that's one example. Donna, would you add anything to that?
I would say that in a district, typically remediation is done after the fact. So right afterwards, we're going to provide a week of remediation. Well, what happens in 1 month? So in 1 month, when they've forgotten how to factor, do we do another remediation because we're not teaching factoring anymore? And the great part about there being one program that has that intensification in it is that it really follows with the students. So you meet Terrence and in this program, and you meet Terrence and he continues to come back and keep coming back, and he builds on the next skill, but you're always going back. So you're not as concerned with the daily mastery because you're going to come back at it again, and you're going to come back at it at a different way. I'll never forget the first week of school, students are doing factoring, but they don't know yet that they're doing factoring because they're building the basic skills of finding two numbers that multiply to give you this and finding two numbers that add and subtract, but they don't know yet that this whole time they've been learning what factoring, they're learning the basics of factoring, but we're actually practicing our integers and we're practicing our multiplication and division facts to get there. So that's just leading forward from what Kathy was saying.
Thanks, Donna, and thanks, Kathy, as well. We have a couple of questions coming in about grade level. So the questions are, what grade level does the data focus on specifically that we showed, and also what grade level are we thinking about when we think about intensification? And since we're talking about Algebra I, we're mainly talking about 9th graders who are taking algebra for their first time in high school. And what's wonderful about that, especially when you think about the motivation piece and the shaping attitudes towards learning that Kathy talked about earlier, is that those skills that students learn are going to carry through with them to their upper level math courses. And that applies really to the mathematics content as well. We know that algebra content provides the foundation for the upper level learning. So we're talking about 9th grade for the most part here. And then another question we're getting from the group is related to training. So what does professional development look like for this? And I think I'll start with this one, but then I'd love to hear also from Donna. What we're gonna talk more about this on the last webinar in this series, which will be an in-depth exploration of one particular intensified algebra program. But professional development is critical. We've talked about how this is a mindset shift for teachers in their approach to teaching struggling learners, and so it's absolutely critical to build that buy-in early. And what we've seen happen in successful cases is that teachers and students actually start having access to or thinking about an intensified algebra program in the spring of the year before they go into their first full year of implementing an intensification strategy. And so they've got it in the spring a little bit to start thinking about, maybe try some lessons out. Then over the summer, they receive in-person professional development like Donna was talking about. And then throughout the school year, there's professional support embedded in one example of an intensification program, and also face-to-face support. Donna, do you have anything to add to that?
It's actually a really good question. I had it in my notes to originally talk about our lessons learned with the professional development. So our first year, 11 teachers, we offered the 3-day professional development and worked in our own district needs, such as curriculum mapping and so forth, in those 3 days. Then what we did was we offered a makeup session, and thinking that any new teacher that would come on could come to it, and all of our teachers came back. What we learned in that first year was teachers needed to come back again as their first experience never having taught this program. We brought them back together again in September. So they implemented in August. We brought them back together in September so that they could really feel like they were getting their challenges and any concerns they had worked out, and share their successes and strategies with us. And then when we went into our second year, which is our first full year of implementation, we only did a 2-day training because we felt, you know, we had our curriculum mapping done. We really didn't know that we needed the 3rd day. And that was our biggest mistake. So going into this summer, it was 3 days, no ifs, ands, buts about it. They really needed that 3rd day. The first year, when you have so many other things going on, it is difficult to understand the value of all of that because, you know, it's one more thing you're trying to learn. But what we noticed last year in our implementation was our teachers who did not attend the professional development during the summer severely struggled to implement the first 9 weeks beyond anybody. And when we pulled them together to have a one-day mini essentials training, they came back and said, we got it. It all makes sense now. That's the value and the importance of this training. So that's the professional support and what we've learned over the last 3 years. We have completely valued our face-to-face sessions that we have because that gives us additional feedback from an outsider coming in and being able to share with us what they're observing. And we've appreciated the professional development that we've been able to offer our principals and our peers and mentors. But what a benefit of this is going back to personalizing it for your district. So you have the opportunity to personalize that professional development, keeping the foundations of what that professional development is supposed to be, but also personalizing it to your district needs and to your student needs, which has really been a benefit for us and what our teachers and our students need. But as Nicole said, the professional development is absolutely critical for the success of offering intensification and intensification experience to students.
Thank you, Donna, so much for that. A next question that we have coming from the group is a great one about the double block. So we have several questions that ask how you keep the attention of a low-level algebra student for a 90-minute block and how that block is structured. And I think, Cassie, the research would be very interesting related to this and also your personal classroom experience. So if you wouldn't mind taking this one.
Sure, because I've actually had that experience in my past classroom life of trying to keep struggling learners engaged for 90 minutes. It is a challenge, and the research is very clear about making sure that you structure that 90 minutes, that double block, whether it's 70 or 80 or 90 minutes, in smaller chunks with very clear breaks. Some of the research talks about 25-minute learning cycles. And you can have multiple cycles within a longer period, but you need to be very clear about when they begin and when they end. So a way to structure that is to think about, many of you use bell ringers, so think about you launch your class every day with an opener, and you're very specific about this opener is ramping into the lesson. It may be accessing prior knowledge. It may be surfacing a misconception, as we talked about earlier. And then you're debriefing that after students have worked on it and really drawing out the mathematics to lead you to the lesson. You might then spend 20 minutes in the core instruction for the day, knowing that you really want to structure it so that students access the knowledge, explore the knowledge, think about the challenging task where we want students to develop some mathematical understanding through engaging with mathematics, and you as a teacher facilitate that. So students don't sit and listen to you passively, but they really work with a partner, and they struggle with a challenging task, and they make sense of that math. You might put your going over homework in the middle of the class, break that up. So that's another nice, there are two reasons you might do that. One of the things that we all know from our classroom experience is that if the time-honored tradition of going over homework at the beginning of class can pretty much become the lesson if you're not careful. And it really doesn't put much of an onus on students to treat homework as something they should be doing to increase their own learning. It almost sometimes seems as though teachers are performing for students. The teacher can do the problems, but it's the students that need to understand the mathematics and the homework. And so by moving homework to the beginning and not leading it as the teacher, but having students do that, and this is what I meant by mentioning a routine where you might flip how you do your homework and think about, students need to be accountable. How do students learn from the work they did the previous night? How do they help each other if they have trouble? How do I as a teacher free myself to observe the students and engaged in that conversation with each other around homework, and notice the 1 or 2 problems that I need to talk about with the whole class. So you're breaking the routine of the 90 minutes into these little chunks where students are always moving to a new activity. You might follow that with some additional deep, rich task work on practicing the concept that they learned in the first part of the class. If you break it up in that way where students have smaller learning cycles and smaller intervals within the class, students tend to stay engaged longer. You give them variety, just as anybody, any adult gets bored doing the same thing every day. So you give them variety, you break it up, you show explicit transitions within the class period. That's one way you can structure that.
Thank you, Kathy. We have time for one more quick question, and then we'll wrap up. And the question is about the distributed practice component of intensification. What does distributive practice look like? And the key thing to think about here is what we started the discussion today with, which was what we have been doing in education for a long time is not working for these struggling algebra students. And what that has been, if you think about a traditional algebra classroom practice, has looked like 30 of the same problems on one page where students practice and practice and practice all at once. And what the research has shown and what our classrooms have found success in doing is that the practice problems themselves are rich problems that are worth the student's time. And so the development of procedural skill is done alongside the development of conceptual understanding, and not a whole bunch of drill and kill type of practice problems all at once and then one word problem at the end. That's not engaging for anyone, and it's not the way intensification can work. And so the quality of the items is important, and also when they happen. So students aren't losing stamina by having to do many, many questions at once. They're doing one of these tasks. Maybe they're working in pairs or a group to do that task, and then they're reflecting on it with the class and with the teacher. And so that cycle of doing a task and reflection, it helps to spread out the work throughout the double block class period. We are at time here, and so we're going to wrap up. I'd like to first just thank everyone for joining us today. Thank you for your questions, and thank you for your participation in the polls. There are 2 more parts to this series. So the next part, intensification in practice, the experience of your peers, you're going to hear from more district leaders who are implementing an intensification strategy. And then in part 3, Intensified Algebra I, you're going to get a guided tour of one example program to implement an intensification strategy. And so that's what was used in Donna's district in Hillsborough that she discussed, and we're going to talk a lot more about that. So there were a couple of questions related specifically to that, and we highly encourage you to tune in and join us then. So thank you again so much. You can register for those events at the address on your screen, and we will hopefully talk to you again.